The elasticity of demand for a good depends on some factors. For example, the closeness of substitution, the proportion of income spent on the good, and the time elapsed since the price change. How the closeness of substitutes impact the elasticity of demand. The closer the substitute for a good or service, the more elastic is the demand for the good or service. Oil as a fuel or raw material for chemicals has no close substitute, so the demand for oil is inelastic. Plastics are close substitutes for metal, so the demand for metal is elastic. In addition, necessities such as food or housing generally have inelastic demand. Luxuries such as exotic vacations generally has elastic demand. As to the proportion of income spent on the good, other things remaining the same, the greater the proportion of income spent on a good, the more elastic or less inelastic is the demand for it. Think about your own elasticity of demand for chewing gum or housing. If the price of gum rises, you consume almost as much as before. Your demand for gum is inelastic. If the apartment rents rise, you look for someone to service. Your demand for housing is not as inelastic as your demand for gum. Why the difference? Housing takes a big chunk of your budget, and gums take little. You barely notice the higher price of gum, while the higher rent puts your budget under severe strain. Time elapsed since the price change also matters. The more time consumers have to adjust to the price change, or the longer that a good can be stored without losing its value, the more elastic is the demand for that good. For example, when the price of oil increased by 400% during the 1970s, people barely changed the quantity of oil and the gasoline they bought. Oil is inelastic, but gradually, as more efficient auto and airplane engines were developed, the quantity bought decreased. The demand for oil became more elastic as more time elapsed following the huge price hike. It is a common mistake to confuse the slope of demand curve with its elasticity. Elasticity of demand is not the same as slope, and a good way to see this fact is by studying a demand curve that has a constant slope but a varying elasticity. The demand curve in this figure is linear, which means that it has a constant slope. Along this demand curve, a $5 rise in the price brings a decrease of 10 pesos an hour. But the price elasticity of demand is not constant along this demand curve. To see why, let's calculate some elasticities. As the figure illustrates, at the points on the demand curve above the middle point, the elasticity of demand is elastic, while at the points below the middle point, the price elasticity of demand is inelastic. At the middle point, the price elasticity of demand is unit elastic. The total revenue from the sales of a good or service equals the price of the good multiplied by the quantity sold. When the price changes, total revenue also changes. But a rise in price doesn't always increase total revenue. The change in total revenue due to a change in price depends on the elasticity of demand. If demand is elastic, a 1% price cut increases the quantity sold by more than 1%, and the total revenue increases. If demand is inelastic, a 1% price cut increases the quantity sold by less than 1%, and the total revenue decreases. If demand is unit elastic, a 1% price cut increases the quantity sold by 1%, and the revenue remains unchanged. This figure shows the relationship between elasticity of demand and the total revenue. As the price of a pizza falls from $25 to $12.5, the quantity demanded increases from 1 to 25 pizzas an hour. Demand is elastic and total revenue increases. As the quantity increases from 0 to 25 pizzas an hour, demand is elastic and the total revenue increases. At $12.5 a pizza, demand is unit elastic and the total revenue stops increasing. At 25 pizzas an hour, demand is unit elastic and the revenue is at its maximum. As the price of a pizza falls from $20.5 to 0, the quantity demanded increases from 25 to 50 pizzas an hour. Demand is inelastic and the total revenue decreases. As the quantity increases from 25 to 50 pizzas an hour, demand is inelastic and the total revenue decreases. Those figures show how we can use this relationship between elasticity and total revenue to estimate elasticity by using the total revenue test. The total revenue test is a method of estimating the price elasticity of demand by observing the change in total revenue that results from a change in the price when all other influences on the quantity sold remain the same. If a price cut increases total revenue, demand is elastic. If a price cut decreases total revenue, the demand is inelastic. If a price cut leaves total revenue unchanged, the demand is unit elastic. This is the end of session 2.